Welcome to the second of 7 lessons in assessing the accuracy of remotely sensed data. I'm Russ Congalton. I'm glad you joined us. And right now we're going to talk about an overview of positional accuracy. It's the second part 2 of these lessons. So the objectives of this lesson are fourfold. One, we're going to make sure we can define positional accuracy assessment, including a little visual example so we all understand what we're talking about. Second, we're going to look at some of the key concepts of accuracy versus precision. Then we're going to review the development of positional accuracy standards, very, very important. And then we're going to detail the steps in the assessment process. So what is positional accuracy assessment? Well, if you look at the Glossary of Mapping Sciences, published back in 1994, but updated since then by the American Society for Photogrammetry and Remote Sensing and others, positional accuracy is defined as the degree of compliance with which the coordinates of points determined from a map agree with the coordinates determined by a survey or other independent means accepted as accurate. So there's a bunch of key words in there, right? We're going to do a comparison. We're going to compare between a map and some other source of reference data. Here it says a survey or other independent means. Keyword is independent, and then accepted as accurate. So we assume that that reference data that we're going to compare our map to is of higher accuracy than the map itself. Okay. So positional accuracy can be done either in the horizontal, which is the XY direction, right? Or it can be done in the vertical direction, the elevation, if you will. Or it can be done for all three coordinates, X, Y, and Z. So here's a little example of what we're talking about. Okay, so you can see that we've got two data sets here. One is a digital ortho or some other digital image, and the second one is a road network. And we've imposed or superimposed the two images on top of each other, the two data sets on top of each other. And if you look at the little inset there, the little stars, the red stars, represent the actual reference data, the what quote unquote, okay, in quotes, true location. If you listen to my introductory modules, you know that I'm not a fan of the word ground truth, and I've been trying to get rid of that term just because truth on the ground is not always real either, okay? But if you put it in quotes, maybe. So anyway, we're talking about the reference data comparison to the road layer, and you can see that they don't overlay exactly on top of each other. The road intersection and the reference points are just not right exactly on top of each other. So what are we doing to evaluate positional accuracy? We're measuring the distance between those, okay, between the reference point and the road intersection. In this case, it's a horizontal measurement, so we're doing X and Y, and we'll do some calculations with that, which we'll show you in lesson number 3. Okay, so visually, you can understand what we're trying to do. We're trying to assess one data set compared to the other where the reference data is assumed to be the accurate data set. So we need to understand some key concepts, this idea of accuracy versus precision. You've probably heard those terms a lot, and they get misused all the time. They get used interchangeably, but they're not interchangeable. Okay, so accuracy refers to the bias of an estimator. So it measures how close an estimated or calculated value is to the true value. Okay, so how close we come to the right answer. You can think of a bullseye situation, and you're trying to shoot at that target. You're trying to hit the very center. How close do I come to that? Okay, precision is completely different. It actually refers to the variability in the estimator. So it quantifies how repeated measures of that same estimator will vary. So you can be very, very accurate, or you can be very, very precise and inaccurate, or you can be, both. Okay? So in positional accuracy assessment, when we take the samples, We use that to determine if a positional bias exists in the map or ortho image or whatever image we're trying to collect. Okay? So in other words, is the positional error significantly different from zero? Or am I not on top of each other? Okay? And we want to estimate the magnitude and the precision of the bias. So we want the accuracy and the precision. Okay, so very important to understand that. Here's a nice example visually. So if you don't like words, you like pictures, I'm a picture guy myself, you can see. It's very precise. You can see the black dot in the center there in A is where we were trying to get. And you can see that these measurements are very, very close to that black dot, and they're very, very close to each other. So we have high precision and high accuracy. Okay, if you go over to B, a little bit more spread out, but so a little less precise and a little less accurate. If you go down to C, you can see that it's very, very precise still. The grouping is very tight, but it's not very accurate, that they're removed from the black dot that you were trying to get. And then if you go to D, you can see we're kind of spread all over the place. We're not very precise, and we're not very accurate at all. Okay, so hopefully that helps you understand these key concepts of accuracy and precision. All right, so this is an important page that we understand and go through a little bit about the process of this development of these standards, these methodologies, excuse me, that are used to assess positional accuracy. Okay, so it's been around for a long time. 1947, federal governments, the Bureau of the Budget back then. We don't even have the Bureau of the Budget anymore. National Map Accuracy Standards. Okay, so you can understand the value of maps, especially from the government standpoint, for military applications, but also for, civil applications, knowing where things are in the United States and how important that is. They started to set up these procedures. Okay, and then along came two gentlemen that worked for the federal government, Greenwald and Schultz, both in 1962 and then again in 1968. They published these government documents called Principles of Error Theory and Cartographic Applications. And this is where a lot of these standards came into place. This idea of these measurements, the use of root mean square error, all kinds of things related to positional accuracy. And every other standard since that time has used the information from the Greenwald and Schultz publications. And so it's been cited in all subsequent standards. I don't know if you're familiar with the American Society for Photogrammetry and Remote Sensing, but a large professional society dealing with geospatial data. And back in 1989, they got together and came up with some interim accuracy standards for large-scale maps. And so a lot of what Greenwald and Schultz and others had done were for maps of smaller scale, 1 to 100,000 or 1 to 250,000, something like that. And ASPRS was looking at for larger scale maps, so 1 to 24,000 and larger. So lots of detail covering smaller areas. And then in 1998, there's a committee called the Federal Geographic Data Committee, FGDC, and that committee still exists today. It's a combination of a whole bunch of federal agencies that get together, and they came up with a national standard for spatial data accuracy, and that's called NSSDA, and that's still the standard that's adopted in the United States today, although there's been lots of things written about it since then. Okay? And then we get more into the digital age, and things definitely changed as we got more and more into the digital data and processing of digital data and computer processing. And so you can see there's a big jump here from 1998 all the way up to 2003. We get FEMA involved, and so FEMA, the Federal Emergency Management Agency, set up some guidelines for flood hazard mapping. Okay, and so obviously elevation becomes really, really important when you're starting to do flood hazards, and with all the hurricanes and tornadoes and all kinds of things that FEMA is responsible for. You can think about Hurricane Katrina from New Orleans, those kinds of things, if you know about that. And then ASPRS got involved again in 2004 and put out some vertical accuracy reporting using LiDAR. Okay, so LiDAR changed things a lot. So having operational LiDAR data, now we're collecting elevation data, not just on terrain that was flat and not just on terrain that had vegetation removed, but now doing things in places where highly forested areas or other kinds of things where all of a sudden it became very, very important to understand that depending on where you're collecting that data, you're going to get different accuracies. If you're in a flat parking lot someplace, you can expect very, very high accuracy. If you're in a dense forest, the issue of the pulses, finding the gaps between the trees, you get much less return, different things happen. And so all of a sudden there was this idea of starting to look at more than one category of map class for assessing positional accuracy. Historically, it was like, okay, let's get 20 samples or 30 samples around an area and we'll be fine. And make sure we pick those as places where we can very easily identify the exact points. Well, that's not so true anymore when you get to elevation data, when you get to LiDAR data, when you get to doing it in places where it's not open environments. And so the classification scheme became an important issue here. And then also in 2004, the National Digital Elevation Program. And so there were guidelines set up for that. Again, all of these are starting to incorporate this idea of different map classes and collecting data in different map classes, even for positional accuracy. Okay. And then the standard we're at right now is from ASPRS, a document that was published in 2014 on positional accuracy standards for digital geospatial data. And the neat thing about this standard is it really goes the whole distance for digital data. Okay. Historically, a lot of the work, especially the work early on, Greenwald and Schultz's work, was all done on paper maps. And so now we've gone and made the whole transition up to digital geospatial data. So there's lots of things to understand there. Can't possibly cover all of it here, but those are the sources. If you want to go back and understand some of the history about that, we cover that in lots of detail in the books that I mentioned at the beginning of the first module of this workshop. Okay. All right. Thanks. So let's look at it in a little more detail. We talked about this a little bit already, but here are the considerations, the issues, the things that you need to think about. Okay, so sources of error, any way you can control those errors, any way you can think about what uncertainty is introduced, any way that you can set up detailed procedures that are objective so that you can make sure that you're minimizing error is a good thing. Classification scheme I just mentioned. Okay, if you're getting into LiDAR or other sources where you're doing positional accuracy assessment, where you've got multiple classes, because it's important that you understand that you're going to get different results depending on the vegetation or non-vegetation that's over the area you're assessing. So classification scheme becomes important. Reference data collection. Again, there's some, what's the source of that reference data? And then how do I sample to collect that? In the next module, we'll look at this in more detail. We need to consider the sampling scheme and the idea of spatial autocorrelation. We need to understand how many samples we need. And then, of course, we calculate the accuracy statistics from that. Root mean square error has already been discussed, NSSDA as per the Federal Geographic Data Committee. Okay, so those are the processes that we're going to go through, and the next presentation talks about that in detail. So let's review, let's make sure we understand what we got out of this lesson. First, we defined positional accuracy assessment. We made sure we knew what it was in words, but we also gave a nice example so that you should have a very clear understanding and be able to visualize in your head what we're talking about. We explained the key concepts of accuracy versus precision, so you should never make that mistake again. These are very different things. Accuracy, how close we are to the right answer. Precision, has to do with repeatability, and so please don't use those interchangeably. We went through the development of the standards, and hopefully you understand how important that was. And there's a lot you can read about that. You can go find those documents and check that out for yourself and see what's happening there. And that's a very interesting thing to do. I've spent hours and hours and hours, hundreds of hours probably, making sure I understand that. And then we looked at the detailed steps in the assessment process, which leads us into our next module where we'll actually start doing some of the analysis. So thank you for joining us, and hopefully we'll see you for the next module.